Assalamu alaikum. This is your computer science teacher Sarfawad Ansari, and today we will discuss a topic of the chapter data representation. This is a basically a huge topic. Chapter, sorry. This is a huge chapter in our chemistry computer science. So data in the O levels. So data representation is the name of chapter, and the topic is text, sound, and images. But in today's class, we will only study topic sound. Text. We only study today text. So let's begin today's class. As we already know that we have got uppercase characters and we also have got lowercase characters, and we are also equipped with different special characters and the symbols like you can see at the rate, hash, question mark, uh, commas, inverted commas, and so on. There are many other characters. I'm not typing all the characters. These are just for example. So these characters basically belongs to the English language. Keep in mind. And you also have got digits. So these are all called characters. Digits and special characters and upper and lower case. These all characters that you see, they makes up a character set. Now we have got two types of character sets in our syllabus. One is the ASCII code. We used to write in the short form ASCII code, and the other one is universal. We also used to call it UNICODE. So these are the two character sets in our syllabus. One is the ASCII and the other is UNICODE. So let's discuss the ASCII code first. So basically ASCII code is the short form of American Standard Code for Information Interchange. So basically this is a standard code for information that we use in our routine life. As we studied in the beginning that we have got uppercase characters and lowercase characters. We also have got special characters or the symbols and so on. We also have got a digit. So these are all related to the English language. So ASCII characters used to support only English characters which are in the English alphabet, English language. So American Standard Code for Information Interchange is was developed for the specific purpose, and the purpose was to input the data via the keyboard. So you have imagined that when you input any character, let's suppose I input X. So how does the system know that I want this character to be displayed? If I input I, how does the system recognize that I want uppercase I? Maybe possible, uh, maybe possible it displays lowercase I, but I do not want this output. I want this output. So how does the system distinguish between the upper and the lower case? So how does it possible? It is just possible because of the ASCII codes. Because there are two categories of the ASCII code. One is for the uppercase and the other is for the lowercase in our syllabus. We will not study that how does the system recognize digits, even though we will not study how does the system recognize the special characters or the symbols. We will only study alphabets as it is the part of the syllabus. So we categorize ASCII code into two further formats. So ASCII code is divided into two formats. One is the decimal or the denary format, and the other format is hexadecimal. So there are two formats that we will study in the ASCII table. One is the denary for the decimal and the other one is the hexadecimal. So these are the two formats that we will study. And in both of the formats, we will study uppercase and the lowercase. This is a thing that's common in both formats, uppercase and the lowercase. So let's go through the uppercase first in the denary value. Now let me draw a table for you. So first column I draw for the character, other column I draw for the denary value or the decimal, character and the decimal. So let's say I first discuss uppercase letters, uppercase characters, and so on. Alphabets starting from A till Z. I am not writing the A, B, C, D till Z. I will just give you the first. So the denary value starts from the 65. Before the 65, there are the codes for the special characters or the numbers. So, but the alphabets start with the 65 in the uppercase. So then 66, then 67 and 68, and the sequence goes on. Now, if I talk about the lowercase, that what is the uh, lowercase alphabets code? That how does the system recognize lowercase and the uppercase? So the codes for the upper and the lowercase is different. For the uppercase, it starts with the 65, but the lowercase start with the 97. But what if I do not remember that what is the code for the lowercase? So there is a formula. If I want to find the decimal code or the denary value of lowercase a, then I first remember that the uppercase code for the alphabet A is 65. When I add 32, then I get the value 97. How is it possible? I tell you later. Now, the code for the uppercase B is 66, and I want to find the value of lowercase b. Then I add 32, I get 98. I want the value of lowercase c. So first I remember the code for the uppercase. When I press plus 32, then I get the value 90. So basically, how does it work? Basically, 32 is the distance between the uppercase character and the lowercase character. So whenever you add 32, you will get the answer of the lowercase characters. So this is how it works: 97, 98, 99. I hope it's clear. And the sequence goes on for the upper and the lower case. Now, what if I talk about hexadecimal? That what happens with the hexadecimal? So it is a little bit different. So how do we deal with the hexadecimal values? First, we discuss the uppercase character in the hexadecimal. I have to increase my number of rows, so I can explain in more detail. So I can compare here G H I J K L. Now for the uppercase only, hexadecimal starts with the first. Then the sequence goes on 43, 44, 46, 7, 48, 49. But after the 49, 50 will not start. Why? Because a sequence will start from 4 to. Because after 9 in the hexadecimal we start the code for the 10. Let's suppose 4 is a sequence, and in the hexadecimal after 9 we have 10, so instead 10 we write the code. Then it goes for the 4b, 4c, and so on. It will go till 4f. After the 4f, let's suppose I write for you here for the better understanding: 4d, 4e, 4f. So after 4f we will start 50, because hexadecimal codes are starting from A. Hexadecimal codes are starting from A till F. Then we start our regular count. Then after 50 till 59, 50 till 59, same counting sequence will be used. But after 59, we will start 5A, 5B, 5C, 5D, 5E, and 5F. So the same sequence will be followed. I hope you understood the concept. Now, what about the lowercase? Lowercase is also same thing. So for the same thing, uh, for the lowercase, I do not know the code for the lowercase. So how do we do it? If you remember that in the denary, what we did, we added 32 in the uppercase. So in the same way, we first memorize the code for the uppercase A in the hexadecimal. It is 41. If I add 20 in 41, I get the answer 61, which is the code for the lowercase in hexadecimal. Then it goes 62. Each time for in the uppercase, you have to add 20. So 20 is the distant number between the upper and the lower case. So 20 will be added every time in the lower case to find the value of the in the uppercase to find the value of the lower case. So whenever you have any uppercase value, you just need to add 20. Then you will get the answer of the lowercase character. So this is how it works. It is pretty simple. Same thing it will be applied here. It will go till 69, 67, 68. Same formula will be applied here. 69, then 6A, 6B, 6C, 6D, and so on. Same formula will be applied here. So I hope you understood the concept that how does it work. But keep in mind, if we convert these characters into the binary form, so ASCII code consists of 7 bits. 7 bits. Let's suppose if I convert 65 into the binary, so how I generate it? So this is the answer. So now this is a code for the binary equivalent 68. How do we make it? Let's write the formula of it. let's suppose I write 1, 2, 4, 8, 16, 32, 64, and 120. Now let me do a little bit alignment of these numbers so you may easily understand the concept. So how do I make the 65? Now you will understand easily. This is how I made the 65. So ASCII code consists of 7 bits, right? But we know that our system used to process the data in the 8 bits. So what happens here? So basically this bit, the last one, it is used as a parity check to make sure that the data has been transmitted successfully. So the parity bit is a topic that we will study in the later on classes in detail. But for now, you just need to understand the concept that the ASCII characters only requires 7 bits to make up a character. So 7 bits are always there to make up a character in the ASCII code. And this last bit is only works as a parity bit to make sure that your data has been transmitted successfully. So basically our character used to form in 7 bits, and this last bit is used to check the data transmission as a parity. Now ASCII code only supports English characters. What about the non-English alphabets? So there's another version of ASCII character which is known as extended ASCII. So this is CII. So ASCII codes, extended ASCII codes basically you are the is the updated version of the ASCII code. So it is a little bit updated because it consists of 8 bits. Now it processes the 8 bits because it contains non-English alphabets as well, but in a limited form, right? So extended ASCII consists of 8 bits, and the non-English alphabets and the characters are also there, but in a limited form. Almost it supports almost 256 characters. Approximately it supports 256 characters, and the ASCII code supports almost 127 characters which are only English based. But ASCII code supports non-English alphabets or non-English characters as well, but in a limited form. So that is why it used 256 character support. But another version which overcomes this method is called the Unicode, which is the universal code. As the name indicates, universal code. So it supports all of the major languages which are using in the globe. So it consists of 16 bits. It consists of 16 bits, and approximately it covers 65,000 characters, non-English characters, and almost all it covers all of the languages, their symbols, their way of writing the digits, their way of writing the um, alphabets. So almost it covers every aspect. But this another private part is designed for those languages that are still not added in the Unicode. And why these languages are not added in the Unicode? There could be many possible reasons. So if there is any language that is not being introduced in the Unicode system, so the developers used to make a private part in the Unicode program. So whenever is someone using the Unicode and the user does not find his or her language, so they may add their language into that private part or the private sector of the Unicode system, so their language will be introduced. So I hope you understood the concept of the ASCII code, extended ASCII code, and the Unicode. But if still you have queries, you may discuss with me. You may contact me on the WhatsApp, or you may contact me on the Facebook, and inshallah I will respond. So thank you so much attending the class.